Assalamualaikum and a very good day. We are from Group 10 and my name is Nafisa Binti Muslim. I will present about introduction. Flooding has become a frequent phenomenon in most countries in the world, including Malaysia. The river analysis system, which is HEC-RAS, is an appropriate setting for this sort of study. HEC-RAS is a one-dimensional study flow model designed for calculating water surface profiles. For importance of study, there are some uses of HEC-RAS. The first one is tool for estimating one-dimensional water surface profiles in multitasking, multi-user network environments. The second one is to create flood condition maps for a number of applications. The third one is simulate one-dimensional or two-dimensional flood dynamics. For problem statement, there is about 33,298 km squared of Malaysia is flood prone. The drainage alur A is an earth drain which connected to Sungai Johor at channel 345 meter. Alur A1-10 shows that those regions were affected by big flood. Therefore, the objectives of this study are to analyze the effectiveness of drain and to provide suggestions on solving flood by section modification. For study area, the selected study area is located at drainage alur A, which connected to Sungai Johor.
Assalamualaikum and hi, my name is Siti Aisyah binti Abdul Rahim, DF 2008-6. I'm going to present the methodology parts. So given data is to conduct study across Sungai Johor tributary from channel 0 until channel 1477.5. From this, we use Manning roughness coefficient n is equal to 0.02 for channel 0 until 599 meter and 0.04 from 600 meter onwards. Next, we use HEC-RAS hydraulic model because this is a hydrodynamic model that may be used to calculate the surface profiles of water under various flow circumstances. It is capable of simulating subcritical, supercritical and mixed flow regimes for streams made up of an entire network of channels. It is also helps to determine the water surface layers that correspond to floods with varying return duration of 10, 50 and 100 years, implying the needs for increasing embankment height or strengthening channels section under different flooding situations. So, by using HEC-RAS, firstly the project starts by considering the channel geometry. After importing the data into HEC-RAS project, click the View Edit Geometric Data and it shows that the river reached the network from channel 0 downstream until channel 1477.5 for upstreams. Based on the information given from the discharge, the channel was designed based on 5, 20 and 50 years. Various adjustments and modifications have been made to the model to avoid the flood from occurs. So this is the 1D model for the Sungai Johor for alur A1 to 10, and this is the original profile plot output from HEC-RAS. And as the result of the modification that have been applied, the river may avoid flood from occurs for the next 5, 20 and 50 years onwards.
Assalamualaikum warahmatullahi wabarakatuh. Thanks for our lecturer, Dr. Adila binti Abdul Aziz. I, Isra Aiman, will explain about the discussion. From the data and graph we get, the output table shows that for the first section, the value of the EG slope is rising from 0.001 to L4 to 0.001309. But the values for the second sector are also rising from 0.04047 to 0.34300, and for the third section, seems like that. The values for the second sector are rising from 0.004047 to 0.034300, and for the third section, also rising. We can infer from this data that a number of things contribute to the EG slope constant increase in magnitude. For the flow area, the statistics before and after are increasing. The statistics for section 1 are rising from 2.39 to 4.05. However, the data for section 2 are falling from 2.49 to 1.23. The trend of the data is increasing and decreasing for the top week and can be seen. Additionally, we can observe a tendency of reducing then increasing for the data from the forward channel. The trends are dropping from the first segment from 0.24 to 0.22 and increasing for the second section from 0.38 to 1.00. This value is subject to variations due to hydraulic flow and section area. So, from the data, we can conclude the value that we get depends on the hydraulic flow and the section area. For the conclusion, it has been demonstrated that HEC-RAS software may help designers anticipate the type of flood that will happen when the plan is put into action in the upcoming year. However, in order to prevent the hydraulic leak, which is currently suggesting the ideal design, HEC-RAS need to advise an alternate to the designer. From this project, we can conclude what should we do as an engineer to prevent the flood from this area. Thank you. That's all from our team.